Hey guys, here's what we have going for you today. We're going to be taking a look at complex numbers. Now, complex numbers are numbers that have a real number and added or subtracted with an imaginary number. And if you don't know what imaginary numbers are, those are um, basically they look like I, and that stands for imaginary. And when you have both of them together, that makes an a complex number. So it's going to look like a plus or minus whatever the coefficient of the I term is. And I'm already assuming as we go through this that you already know how imaginary numbers work. You know, I squared, I being I equals the square root of -1. And so I'm already assuming that you guys already know all that stuff. And we're going to move forward as if you already know this. Now, if you don't know this, please reach out. Ask me a question. You can go review it. I don't have a video just explaining what imaginary numbers are and how they work. But if you need to do that, you could go to my website, mrhernandezteaches.com, and you can find the notes for that. But we're going to move forward with simplifying complex numbers and see how they work. The trick with simplifying complex numbers is you're always going to be looking at them as if basically they are basically variables. And so, if they were x, what would you do with them? So we're going to start here with this problem. And I see this minus sign, so I want to distribute. And I'm going to continue to treat these i's basically as variables. So the parentheses here does not matter. There's nothing to distribute in front of those. So 9 plus 7i minus 6, because minus times a positive 6 is -6, and plus 2i. Okay. Now, now you just want to combine your like terms. So 9 minus 6, that's going to be 3, and 7i plus 2i, well then that's going to be 9i. Because if this was an x, it would be 7x plus 2x, and I'd have 9x's. Well, we have an I, and those are imaginary numbers. And this would be your final answer. When you're working with your final answer, you always want your real and then your imaginary part. So again, going back to that form that we had just a minute ago, a plus bi right there. Ooh, that was a big circle. Alright, so but a plus bi, and we are in that form. You don't ever want the I in the front. That's just syntax, but it makes things a lot simpler. Now on to our next problem. 3 plus 11i plus 10 plus 9i. So I have addition here, and there's nothing to really distribute, so I'm going to drop all my parentheses. That was supposed to be 3. So 3 plus 11i plus 10 plus 9i. Be careful, you don't want to make your eyes look too long, because it'd be like one weird looking one. But then we go through, combine your like terms. So 3 plus 10, we got 13. 11i plus 9i, that makes 20. So 13 plus 20i, this is a 13. That would be my final answer. So we're going to keep on going through just using that. As we're simplifying complex numbers, it's just going to be the same deal. So here we go. Here's another problem. And I have multiplication happening. A little dot in there, multiplication. We're going to distribute first. So 1 times 3, we're going to get 3. Outside, so 1 times 2i, that's positive 2i. Inside, negative 9i times 3, that's minus 27i. And then last, negative 9i times 2i, that is going to be minus 18i squared. Because if these were variables, they would be squared. So now I just combine my like terms. So 2i minus 27i, that's going to be minus 25i. then minus 18i squared. So like I said, I'm assuming you already know that this I squared equals negative 1. So we're going to substitute that in. So 3 minus 25i minus 18. And we're going to replace this I squared with a negative 1 because we know I squared is negative 1. So now it's going to say 3 minus 25i. And negative 18 times negative 1, that turns it into plus 18. And look, I have more like terms to combine. So 3 and 18, that's going to give me 21 minus 25i. And again, making sure your I is always your second term. So 21 minus 25i. Don't forget, I squared equals negative 1. We got one more going on. And here it is. So this one's going to be quite a beast, but still follow it, treat everything like it's a variable, and then go back to your definition of imaginary numbers. So this is going to be squared. So basically I have to square the first and the second. So that's going to say 9 because 3 squared is 9. And then I squared, well, that's just going to be I squared. And yes, that will be negative 1, but we're going to handle that after everything else. And now this minus 3, we're going to distribute everywhere. So negative 3 times 1, that's going to say minus 3. Negative 3 times 5i, that's going to say minus 15i. Now I squared, that's going to be negative 1. So I'm going to put that in. 9 times negative 1 minus 3 minus 15i. Well, 9 times negative 1 is negative 9. And now minus 3 minus 15i. Okay, so negative 9 minus 3, that's going to be negative 12 minus 15i. And again, my I is the second term, and that'll be my final answer. Now, how can you check this? How can you know? And I'm always into checking, and I'm always into the calculator. So on your calculator can handle imaginary numbers, but you have to tell it that you're looking at imaginary numbers. And so you're going to go over here to mode, and where is it? So right here, normally it's going to say real. Basically, you're only dealing with real numbers. But now we're going to be starting to look at complex numbers. See how it's in that form I was telling you about earlier? So hit enter and it's going to switch it over. And so now there it is. So I is going to be second dot. Alright, so I. And so we know I is going to be I. And that we know second I squared is going to be negative 1. So see how the calculator knows all of this already? So if you want to check it out, I believe this works. Someone told me it works. If it's going to happen on the video, it's going to work. So 3i squared minus 3 parentheses 1 plus 5 second I. And isn't that what we ended up with? Yes, it is. So the calculator can do it too. I didn't show my class this just because I don't want them to just get addicted to the calculator. This is good algebra practice. And honestly, you need to know the definition of imaginary numbers as you move forward in pre-calculus and quadratics and calculus. You need to know how imaginary numbers work. They're very, very simple to use and very, very powerful. They really add a whole new dimension to mathematics. But that's how you can check. You can go through this problem algebraically and then check your answer at the end, so you always know if you have the correct answer, or you can go back and check your work. But if you do need more help with this, my name is Mr. Hernandez, and I'm always here to help.